So, as you know, the hands-on for today will be a beginner-friendly crash course to Kubernetes. I'll do a little poll just to know what type of profile is here today. So, how many of you are data scientists? Okay, majority of you. Nice. How the rest? What are you more? Data engineers, MLEs? Okay, cool. Nice. So, yeah, I'll try to keep it as friendly as possible. Most of the things we'll cover are basic as per Kubernetes standard, but these are like really basic concepts that will help you understand what are the moving pieces and like what things you need to worry about, what things you don't need to worry about, and what happens a little bit under the hood, so you understand how all of this like makes a cluster together. So today's plan, we're a little bit behind schedule, but no worries. So we'll have a 1 hour presentation on concepts and basics. So you get to see what I tried to introduce just before. 30 minutes setup. Depending on your operating system, who saw my message yesterday on Huva? Okay, one person, cool. Two people, nice. So we won't need as much setup. Just for the people on Windows, you'll just need to install Docker Desktop, and the people on Mac, you can also. I think you can also install Docker Desktop. However, you just might need to create an account on Docker Hub so you can have a cluster running locally. But we will have time to do that. And then we'll have 45 minutes lunch break, and we'll start again at 1 p.m. up until 2:30 with the hands-on. I prepared for you a hands-on workshop. I'll share with you the link on GitHub later, and you'll be able to follow along with the different steps. So yeah, we'll cover several things like deployments and whatever, services and whatever. And if you're really strong and you finish all these steps before, you'll even have bonus exercises. So yeah, let me start by the introduction. We'll cover really basic things like what is container orchestration, what is Kubernetes. Then we'll get into the big part, which is Kubernetes architecture. Here we will try to get you introduced to the concepts of scheduling, how a pod gets scheduled on a node, and what is a control plane, what is a node. We're not really getting into the details, but it will be just enough for you to understand how a pod gets scheduled, basically. So yeah, once the architecture introduced, we'll talk about other resources, which are basically the resources you'll be using to provision the different parts of your application, like pods, deployment, services, namespace, all these things. Right now I'm just dropping names, but it will make sense later. And once we've talked about all these components, we'll kind of talk about the concepts behind the different ways to deploy your application on Kubernetes. So we'll talk about kubectl, kubectl, kubecontrol. You can call it the way you want, but this is basically the CLI tool that will be heavily used to interact with the cluster. So yeah, just in case I haven't said it before, we'll use the command line quite a bit. So I hope this will also be an introduction to this wonderful tool that is the command line. We'll talk a little bit about imperative deployments as well as declarative. We'll set up Docker Desktop or whatever works best on your operating system. As you know, I work for rocket science development, so I'll also introduce rocket science, the MLOps Institute, and the resources. So let's first start with this first question. What is container orchestration? As you know, many of you have to had to work with infrastructure teams or DevOps teams, depending on the label you have within your company. And the thing they were mentioning the most is, oh, the container, whatever container, the container has to be running, the container has to be up. So when you get into a certain scale, you will need to find a way to manage an increasing number of containers. So when you have, let's say, 5 containers, you can kind of easily manage them manually. But when you get to 100 containers spread across 3 different environments, think of a container as a component of an application or an API that is serving a model, or even in some cases, you have an inference pipeline, and every container, one after the other, is like a pre-processing or a post-processing step before or after the model's prediction. So you'll need a way to handle all that part. So this is where container orchestration gets into the image. So to sum it up, container orchestration answers the need for automating the operational effort required to run all the workloads and services of your applications. It can range from a simple basic model up to an inference pipeline that has chained containers one after the other, or even more complex applications that you can find either in enterprise or even the simple applications you install from the Google Store. Most of the time, the backend might be running on such clusters. So yeah, as I said, helps to manage containers and microservices at scale. There are many container orchestration tools that already exist. Just to give you a broader view of container orchestration. So of course you have Kubernetes, HashiCorp Nomad, Docker Swarm up to a certain extent, and Apache Mesos. However, the two that are the most maintained and talked about are Kubernetes and HashiCorp Nomad. However, for MLOps, I do have a preference for Kubernetes. HashiCorp Nomad, the community tries to do things, but in Kubernetes, it's way more active because you find way more people working on ML and MLOps related solutions such as Kubeflow, and you even find easily application packages to install on Kubernetes for Airflow, let's say, and things like that. So yeah, that was a small digression. So why Kubernetes and not other solution? First, it has multi-cloud support. The main cloud provider have a version. You have GKE for GCP, EKS for AWS, and AKS for Azure. So they have main support, and they have teams who contribute quite frequently to the Kubernetes project itself. Second, there is an extensive community support. You can easily find manifests and packaged manifests. We'll see what is a manifest later to deploy different MLOps tool on Kubernetes. So that's the second thing, is like what you learn today, you might be able to better understand the context you'll be working in if you have to work on an infra that runs on top of Kubernetes. And also there is an enhanced portability and flexibility. So what I mean by portability is like if your infrastructure, if your operations only depend on Kubernetes, you can more easily go to another cluster. Let's say you have an application running internally for a product you develop, and tomorrow you have a client that has certain security requirements and can only run inside the private Kubernetes cluster. You can easily take these manifests and be able to deploy them on that private cluster. So that's for the portability, and then for the flexibility, you have you have things that Kubernetes doesn't do right away, so you can always install custom resources, extensions, and things like that. So it's always helpful on these aspects. And finally, it's open source and it's supported by the CNCF, which is a branch of the Linux Foundation. So you'll always have a certain quality of contributions to the project, and it always has like a roadmap for the different versions and everything. So there is support on that aspect as well. So what is Kubernetes? As we already know, Kubernetes is a container orchestration platform for Linux-based containers, because other container orchestration solutions might focus on other aspects than only Linux-based containers. And if you want to have an in-depth story about Kubernetes, you can check this two-part series by Honeypot on YouTube. It talks to the main actors that contributed to the development of Kubernetes, and it's really interesting. It gives you another perspective on the story behind Kubernetes. So let's dive into to the important part. So first, let's start by defining terms. So what you'll hear a lot about when it comes to orchestration in general, and specifically in Kubernetes, you'll hear about a control plane. The control plane is all the processes and services that help you control workers, and this is where all the assignment, scheduling, tasking, workload distribution, etc., will originate. So it's basically the head of the cluster, the brain of the cluster. And then you'll have the worker nodes, which are either virtual or physical machine on which all these workloads will be scheduled to run. So your pod will run on a node, and it will be scheduled by the control plane. And then a cluster is the collection of both control plane and worker nodes. So how does Kubernetes solve the challenges of container orchestration? I'll stop writing text for now, and we'll get into some diagrams. So as you can see, first you have the cluster. On one side you have the control plane, and then the several nodes. On the nodes you'll have two elements that will run on the node. One is called the kubelet, and other the kube proxy. The kubelet itself will be the element that will interact with the control plane to schedule the pods that will be running on the node. The kube proxy will handle more of the networking part in accordance to what the control plane tells it to do. So let's say you are using a command to create or to provision a pod on your cluster. So what happens is that you have a component inside the control plane that's called the kube API that will receive the command, and then it will send the signal to the scheduler. And then the scheduler, according to other tools I won't mention here because I want to keep it simple, will know how to schedule, plan, and deploy what pod on what node, and it will send the deployment signal to the node's kubelet to deploy one or several pods. So yeah, that's a really summed up way of talking about how Kubernetes does that. And thanks to the control plane, there are other aspects that can be handled with that that are related to node health, pod health, and other things, of course. So this is how the cluster on which you provision your elements will kind of work. But the resources you'll interact on a regular basis will be things like namespace, pods, deployments, services, config maps, volumes, and many other things that even experienced people keep learning about almost every day. So in the next part, I'll start explaining the different parts. So let's start with the namespace. A namespace is a mechanism that helps you isolate group of resources within a cluster. And having that isolation mechanism helps you also assign quotas. So if you have several namespace on the same cluster, because one cluster can be shared by different isolation that can mirror either business units or environments like dev, QA, UAT, prod, you'll be able to assign specific quotas to each environment, so you make sure one namespace doesn't take too much resources. Because trust me, if you talk with your cluster admin about namespace getting out of memory errors or like not enough resources, it's really tricky to solve that. So you always have that option to apply limits and resource quotas on the different thing. So I can give you an example. If you have a container that depends on a powerful VM or physical machine to make predictions. So what happens is that you can assign a specific limit to either that model container or the namespace inside of which the container is running in, so you avoid having your machine getting into sort of a frenzy and trying to scale up into infinite numbers of memory. That's kind of a nightmare scenario, but this is what happens. This is what happens usually when you don't put quotas, is that the components will grab too much resources. So yeah, so you have your namespace. As you can see, you have your Kubernetes cluster, your different nodes, and you have, in a really adjacent way, different namespaces. Here I call them namespace 1, 2, 3. You can call them dev, QA, UAT, or whatever. So this helps you having a sharing of resources. So the next element is a pod. So this is where the serious thing begins, because the pod is the smallest deployable unit inside Kubernetes. So a pod is a group of one or more tightly coupled containers. So you can have one container inside the pod, or several containers, depending on how complex that unit of your application is. But usually when people designate a pod, it's usually also a container in Kubernetes, even though it's not a rigorous way of using the language. But usually when you say a pod on Kubernetes, it's usually one container, but you can have several containers inside one pod. Since it's the smallest deployable unit, it's also ephemeral. So if you delete one pod, it won't restart. You have other types of abstraction to help you with that permanent thing. So as I said, when deleted, the pod doesn't restart. And you can also schedule it with affinity or anti-affinity. Here we get into some really detailed things. Let's say you want a specific pod to avoid running on specific nodes. Let's say you will have, on your cluster, you will have nodes that have the sole purpose of being used for model training. So you'll give them a tag, you'll give these nodes a tag, and then what happens is you can say if a given pod can run or not on this group of nodes with that kind of rules, or if you don't want two pods to run on the same node at the same time. And as I said before, you can also apply this limits and quota logic to pods as well. So again, I take the example of the model that is quite resource intensive to make inference. So you want to avoid having it or the pod grabbing so much memory that it makes the entire cluster crash. So you have that type of limits to help prevent that. So the second component is deployment in the replica set. So basically, it's an abstraction on top of pods. So it helps you configure a replica set which has the parameters to say how many replicas of that pod you want running at all time. So as I said, one pod is ephemeral, but if you want to have 3 pods running at any time, you'll use deployments in order to specify this replica number. So if you create a set of pods through a deployment on your cluster and you delete one pod, the control plane automatically knows that there needs to be, let's say, 3 pods existing at any time. So it will restart that. It will restart another instance of the pod you deleted. Again, as you can see, you have the pod abstraction. On top of it, you have the replica set. And then on top of it, you have the deployment. That's how you have to think about it. You have abstractions that are contained inside each other, and this helps you make more sense out of some more complex concepts in Kubernetes. Again, you have one specific type of deployment. It's called the daemon set. So basically, a daemon set helps you run the different replicas on different nodes and only have one instance of a pod on each node. So basically, what happens when you schedule a deployment? Usually, you'll have a group of pods running on the same node. But if you want to only have one pod per node for a deployment, you have this option. So now we'll get into the more networking part of Kubernetes. Just before I introduced the abstraction of a pod, which helps you deploy units of your app. Now we'll get into more of the way related to how you can expose your application either inside the cluster or outside the cluster. So as I said, it's a component abstraction that exposes a pod as a network service. So you'll have your pod existing, and then next to it you'll have your service, which kind of does the routing of traffic that is coming into the pod. So this, as I said, it exposes the pod internally, and it's really useful when it comes to the communication between pods, because what this helps you doing is not typing every individual private IP address of every individual other service or pod that is running on your cluster. So yeah, it prevents a lot of trouble. And then there is the ingress, which is also another networking related abstraction. And what an ingress does is it helps you exposing a specific part, like a specific pod or deployment, to the outside. So it allows users having access to a front end or an API endpoint if you are providing some API services. So you have several types of services. You'll find the cluster IP. So this exposes the service on a internal cluster IP. Then you have the node port, where the service will take the node's IP address and will be exposed on the port of that node. And then you have the load balancer. The load balancer is a bit more tricky and advanced, but I'm still introducing it. It's sometimes to challenge ourselves. So it exposes the service externally using a cloud provider load balancer. So you'll find more of that load balancer type when you're deploying on some cloud provider managed cluster. As I said again, so the ingress, which exposes a specific deployment or pod to the outside, it can expose it through HTTP or HTTPS. And it helps with routing the traffic according to rules. It's more on the infra side, but you need to be aware of it, because that's one of the main uses of Kubernetes when you deploy an application, is that you can specifically tell which which component or microservice can be exposed to the outside and which aren't. So you can have that type of isolations in the rules. So naturally, Kubernetes doesn't do ingress. What I mean by ingress is having some parts of the routing control running in the cluster, so you have extensions and custom resources to help with what's called ingress control. So you have many of them in the ecosystem, but the most used one is Nginx controller. So now let's move on to the next part. Sometimes when you run a pod, it's basically your container that is running, and you're wondering, okay, how do I inject configurations inside that pod so it can run according to the specific configuration inside my environment? Because you don't want your application to have the exact same type of configuration when it comes to having something running in dev and running in prod. For example, turning on and off the debug mode in some specific environment. So the first element is a config map. A config map helps you injecting non-confidential configuration files or environment variables inside your deployment or pod. And then you have the secrets, which are the more confidential config files. So it can be credentials to a database, some certificate when you get into HTTPS, let's say, and other things. So you have that type of difference between non-confidential and confidential information that you inject inside your pod. Just a small note for the secrets. You have also the need to get custom resources or extensions in order to behave or interact with the secret vaults. That's a small digression. Once we've passed the secrets, what the Kubernetes does basically, it helps you run stateless application. So what we mean by stateless application is that you don't have to persist data at any point in time. So you also have other components which are in the family of volume, claim, storage classes, and stateful sets, which help you add a bit more extension to the Kubernetes API in order to handle data and states to either buckets or databases. So that was it for all the elements. I can feel that I quite overwhelmed you as of now, but it will make sense during the actual hands-on part. So there are several ways to deploy your application on Kubernetes. The main one, the main one that everyone uses and will use today is through the command line interface called the kubectl, kubectl, kubecontrol, whatever pet name you want to give it. And this is your main tool to interact with your cluster. So it helps you define two important parameters: is what cluster are you connecting to, and what namespace are you sending the command to, or where you are provisioning the resource inside. So the first way to use kubectl is to deploy or delete the imperative way. What I mean is you have kubectl and you use the 10 flags to describe the object you want to deploy. I didn't put it as an example because I find it quite horrendous to look at, but basically I don't advise you to do it. To do like create a pod with 10,000 dash flags. So you have long commands which are less readable, more prone to error or typos. You always have to retype it. What I mean is, like, even though in your command line you press on the up arrow and you have your command again, you still have to correct it. So it counts as retyping. If it's not in a script bash, of course. And it's less easy to keep track in change of resource parameters. Let's say you have some path on which you're mounting some volume inside the deployment that changes. It's very hard to keep track of it. So that's why we prefer to go for the declarative way, where you have your entire resources described inside of YAML files. So YAML everywhere and YAML engineers, you already heard that joke somewhere. So this is the declarative way. So you describe your object or your component inside the YAML file using all these amazing indentations and hair pulling sessions when you're trying to deploy something, but it's part of the fun. So yeah, YAML is your friend. So basically what you will do in that case is you'll use different fields that help you describe what version of or extension of the API you're calling, what kind of object you're deploying, what's the name, what's the label, and different other configurations that are related to that. This is a bonus. There is a tool called Customize that helps you do some sort of patching on top of YAML files. That's part of the bonus exercises, so don't worry about it. So I finished my presentation about Kubernetes. So now let me introduce quickly Rocket Science, the company where I'm working at. So we're a company that specializes in everything related to MLOps and machine learning engineering. So if you have any questions or interesting use case or challenge you would like us to help you with, don't hesitate to get in touch with me or any member of the team that you see wearing my T-shirt or having the company name on the badge. And we also recently created the MLOps Institute, which basically focuses on helping with the spread of everything related to MLOps. So what we're doing currently is we're developing a certification related to MLOps. And the Kubernetes presentation you just saw is like a small glimpse of the content we're developing right now for that. So also, if you're interested in joining our first cohort, don't hesitate to get in touch with us. About me, so as you know, I work at Rocket Science, and I'm a machine learning engineer. However, if you want to get in touch either through code or LinkedIn, you're always welcome to add me. So here is also a list of resources I used because all these things didn't come out of nowhere. So I can share that slide deck later also on my GitHub, and you can always look that up. So now let's move on to the hands-on part of the workshop. So first, let's do so by doing the setup. To all my Windows people, I have a question. Did you install Docker Desktop? Okay, maybe you can also install it on Macs as well. So meanwhile, my co-speaker Asim can introduce the MLOps Institute a bit.
So good morning, everyone. Welcome to this hands-on workshop that we already have for with the Eric, but with the presentation, sorry, but we'll have a hands-on after this once we come back from the lunch. So my name is Asim Sultan, and I'm actually a senior consultant and an MLOps engineer at Rocket Science Development. We are working on MLOps Institute. So we did some R&D on various certificate and certain course providers. So for instance, on Coursera, Cloudera, we were looking at how somebody from very basic software development experience can get into MLOps. So somebody who doesn't even have experience with the machine learning and how all of this stuff work. So we at Rocket Science, we are creating a certificate that is basically MLOps Institute. So what we are doing is we are starting it for the people who have little to no background with software development. That's basically a 12 weeks course. So in the first week, we'll just introduce software development in general. We'll introduce Python, then we'll have machine learning, like only those parts that are required for you to take your first step into MLOps stuff. After that, we are covering containerization, like Docker. We are working then on the Kubernetes. We are covering CI/CD pipelines. We are using GitHub Actions. We are using Jenkins. We are working on various data pipelines, so on DAG stuff and all that. Then we are also covering the Kubeflow, MLflow. So these are some of the things. So basically an end-to-end complete certificate on the MLOps, and that is available on the MLOps Institute. So you guys can give a look to that certificate as well. And as per our research, till date, there is no certificate which is actually taking a very beginner software engineer from from learning machine learning all the way to learning the the MLOps end to end. So yep, this is something that we have to offer today.
Thank you, Asim, for this short introduction. So what I'll do now is I'll walk from group to group to see if you were able to install the tools as needed. So yeah, I'll going from table to table, and don't hesitate to raise your hand, and I'll come and help you right away. So, a lot of you had the same question about creating the cluster on Docker desktop. So let me get it for you. 1 second, please. So. Are you all able to see the interface? It's kind of small. So once you open your Docker desktop interface right there, the first thing you need to do is wait for the whale, which is the icon for the Docker engine, to turn green. Once it's done, you click on the gear icon right here, and you go to Kubernetes, and you click on enable Kubernetes, and you apply and restart, and it will start up a Kubernetes engine for you. So on my part, oh, okay, error happens. So what happens, for example, on my end, I'm using Windows Subsystem Linux. Let me get it bigger again. Yeah, it's not beautiful. Anyways, now you can see. So once the Kubernetes icon turns green, from my end on Windows Subsystem Linux, it injected the kubectl CLI. So I can do it like that. Kubectl version -- client. Oh, small typo. Okay. So I got the different versions as expected. So I assume on your MacBooks, once you start up the Kubernetes engine, it will inject kubectl directly into your environment, and you'll be able to use it. And that's the first thing. You can type kubectl version, and it will print out the version for you. And then the second thing you can do, just to check that you have a Kubernetes cluster running, but it's just like one node cluster, you can do kubectl get nodes like that, and you can see that you have one node running. Did that answer most of your questions when it comes to running up a cluster on your machine? because that was a recurring question. So does that did that work for you guys? Perfect. More help? I didn't work. It worked. It worked. Okay, good. That's okay. I'm coming. I'll do it right now, and I'll push it. So, in the first steps, right here, you don't need any of that. Okay. Remove unnecessary steps. So now if you refresh your page, you won't have these two steps that confused a lot of you. Do you have any more questions? I think the lunch break is soon. You can go now, and we'll be back at 1 p.m. and we'll walk through every step together. It will be a kind of a follow along thing. So we took the time to set up everything. I'm still available if more of you need help. So see you later, guys. I hope you're all well fed. You have a lot of nutrients, and you're ready to focus a little bit. So this second part will be the actual hands-on. So we helped you set up your different laptops earlier. So I think by now you'll be able to follow along. So there are two first things we need to do is to make sure that we are having our cluster running. So the first one, way of doing it is actually going to your Docker desktop, as I showed many of you earlier. And I don't have Wi-Fi. 1 second. Connect. So we'll check if the cluster is running through Docker desktop, and then I'll show you another way to see if the cluster is running on your machine. Okay, so I'm connected. That's perfect. So louder? Okay, I'll talk like that. So when you go to Docker desktop, you click on the gear again, and to Kubernetes, and you see that you tick enable Kubernetes, right? That's the first way. And you can see that it's running because you have the small icon on the bottom left that says Kubernetes running. So you're 90% sure that it's running, but just in case of doubt, because we doubt a lot, just in case of doubt, we can go to the command line, PowerShell or whatever, to check if there are nodes running. So you can do kube control get nodes. And oh surprise, you can see that you have one node, your amazing one node Kubernetes cluster that is running on your machine, and you're ready to start your adventure in Kubernetes. Okay, so that's the first step. That was a big step, but nonetheless, the first step. So now let's go to the repository, the hands-on sample. So let's start from the beginning. Okay, let's make it. Okay, it's a bit smaller, but you'll still be able to see it. So first, I assume that all of you built the image. So just in case, I'll do it as well. Docker build -t sample -api dot. So basically, I assume that you're already familiar with containers, but just in case, just to sum it up, so basically you have a file called Docker file that explains all the steps to build your container image that will package your application right here. So here we build it. Mine will go faster because I already built it in the past, and one of the features of Docker is that it keeps in memory all the previous steps. Yes, do you have a question? Oh, Asim, do you mind helping our friend? So right here we build the image, and thanks to the Docker desktop or any other local application, you'll have a registry locally on your machine, and this registry will be used to later deploy the different pods or deployments. So that's the first thing, that's the Docker step. How it translates in enterprise environments is that you will have a pipeline that will build the actual image and push it on what we call a container registry. So we kind of did that step locally right here on our local machine. So that's the first step. We containerized our application. Then we have kind of an intermediate steps or things to do when we do next. So as I said earlier, there are two things you need to let kubectl know: the context, which is which cluster you want to do the commands on, and the namespace, which isolation within a cluster you want to do these things on. So personally, since I'm using Kubernetes quite often, there are two tools that help me do that. It's kube context and kubeNS, just as a small reference. But you can do this context and namespace directly with kubectl. So the first thing we can do with kubectl is get the context. So it's quite transparent. Kubectl config get context, and as you can see here, I'm having several different contexts. So the next step is as you can see, I already selected Docker desktop, so there is no need for me to set the context to Docker desktop. And also I'm using a command line tool that shows me in a quite visual way which context I'm in, here on the right. So I'm again assured that I'm in the right context. So right now I want to see which namespace I'm using. So I'm not sure about which namespace I'm using, but one way of being sure that you are always applying the right command to the right namespace is by using the -n parameter, and then enter the name of your namespace, which says, okay, do that command on that namespace. Because trust me, sometimes you don't want to deploy the pod to the wrong environment, like a container version that is still in development on production. That kind of error happens sometimes. I don't really advise it, but some people like to live on the edge. So in order to do that, I can list all the existing namespaces by doing kube control get namespace. But here is the small thing. Sometimes you can feel lazy, and instead of typing get namespaces, you can just put ns, which is a small diminutive for namespace. So this gets quite cool when you get long object names. Usually there is a way to write it faster with less letters. In some cases, you really don't want to. You really don't want to keep typing and do other things. So you want to make also point your kubectl to that namespace at all times. So you can do it like this, namespace. So you set your kubectl configuration to the namespace called frontend. And like through my tool, I see that I am in frontend. But if you don't have these little visual tools, you can always use a command which is kube control config view with pipe grep. I know that most of you aren't familiar with the terminal, but one thing you can do for fun, you know, instead of learning of the latest and greatest model with 10 billion parameters and never knowing when you will apply it, you can actually try to learn command line tools, which are more useful than the latest model that has 10 billion parameters and can only run on 100 GPUs. Data scientists understand. So yeah, once you press that, you get to see that the config is pointing to frontend as well. So okay, we made sure we're running on the right cluster. We won't push our deployments to the production cluster, and we won't push our deployments to the production namespace as well. So we double checked. Okay, that's these are small ways of making sure. It's like in carpentry, they always say, measure twice and hit the nail once. So we can all learn from this wisdom. So now let's move on to the second step, which is about deploying the actual deployment. So let me open briefly the file, the deployment file containing. Yeah, can you see now? Yeah. Okay. So as you can see, this is the YAML file. YAML is your friend. Often people who do specialize in Kubernetes call themselves YAML engineers. So they spend most of their time modifying these types of file. So you can see a certain pattern here. So you have your API version, which is to which extension or module of the Kubernetes API you're calling, and the type of object you're using within that extension. So here we're deploying a deployment, kind of redundant, but that's the idea, and we give it a label, which are as you guess labels, and helps you identify your specific application components according to environment, uses, and app name. You have the name, of course, and as we will see a bit later, we have the replicas. Here we are identifying 2 replicas, but if I change it to 3, and I'll ask for the cluster to provision me 3 replicas of that deployment, what it will do, it will have the deployment object, but 3 instances of a pod that are assigned to that deployment object. I'll show you later. If we delete a pod that are among the specified replicas, it will auto-heal by creating a new instance of a pod to always keep it at that number. So one cool thing about Kubernetes is the self-healing capabilities. So you can always have that quite useful. You can also have things a bit more advanced, like selectors. They are more useful when you want to attach some object to other objects. Let's say, for example, a service. You want to attach it to a specific deployment. You'll use selectors. And then you have other things like template and everything. So this body template here will help you specify labels, annotation, and everything that you want to be templated for every instance of pod that will be deployed by the cluster later. Oh, yeah. I already zoomed, but Is it better now? Okay. And then you have the specs, and this is the part where you specify the many containers that will be running inside your pod. So you'll have the image itself. Here we are calling it sample API latest because this is the image name and tag that is on the local registry here. But usually what you can do is have that image pointing to a container registry that is running somewhere on the cloud, for example, and you can have a container registry for images that are in current development and etc., etc. And you can also associate names to the container and image pool policies as well. And you can see here commented other things that are related to volume mounting, secret mounting, config map mounting. We'll see that in the later steps. So let me get to a tool that helps me have several windows open at the same time. No. Okay, perfect. So here we can have watch kubectl get pods. So as you can see for now, on the right, we don't see any pod that has been found yet. Okay, so now I'll do kubectl apply -f because you're originating your deployment configuration from the YAML file from deployment.yml. Like I know that in the README it's YAML, but it's like a funny convention because there is a small controversy between YML and YAML, but it's not important. It's just a running gag between YAML engineer. So you do kubectl apply, and oh, it's telling me kubectl not found. Okay, so as you can see, both of them are failing, which is normal. It's because the code inside is requiring some files. We'll get that fixed in the later steps, but I wanted to show you what happens when you deploy, when you use a deployment. So as we saw, there are two replicas that have been defined in the deployment itself. So right now, if I try to do, I use K, it's an alias for kubectl, just in case you have any doubts. So if I do K delete pod, whatever front end here, let's take the first one here. So as you can see, the one I asked to delete has been terminated, and automatically the control plane knows that there has to be always two replicas at any time. So it started another replica while the other one was terminating. So this is what happens to pods that are assigned to a deployment, is they have a self-healing capability. Because if we had a random pod running and we did delete, it wouldn't have had restarted. Is it, I'm going a bit further than what's on the README, but just things that are more visual when they are explained live. It's okay for anyone? Are you having enough information about that? I can go a bit further if needed. So we got to step 2, we did the deployment. Now we're going to the service. So just to make it clear, your deployment or pod is the abstraction that is containing your container that has the container inside and will actually make your application run. Now we're going to the abstraction that helps you expose that application either inside the cluster or outside the cluster. So let's move to the step 3.1. We'll deploy a service. So let me. One second. Okay. So now I'll do a watch on the services, so we can see what services are created in real time. So there is already another service running. Let me delete it real quick. So unlike deployments, services don't have that same logic as replicas. So they're ephemeral. So you need to keep that in mind. So yeah, delete SVC, which is for service. The name is frontend. The name is frontend SVC. I deleted it, and as you can see on the bottom here, it disappeared. So this will allow me to go and do the step 3. So step 3. So if I do an LL, okay, cool. I tried to do an ingress, but it didn't work great, so we'll kind of skip that, but we'll use another alternative, which is more often used for local development, which is port forward. So as always, I'll do kubectl apply -f, and then the YAML file that contains the services. The services description, and poof, as you can see, we have front-end service with a node port type, with a node port, which is node port type that is open on the port 3000. So yeah, that's for the that's for that. So yeah, I put the ingress creation as optional, but we'll go for the port forward alternative. So I'm mapping the port 3002 inside the service to the port 3000 of my local host. So I'll try to do localhost 3000, but I'll let you guess it will fail because the pod itself is failing. So if your pod has a failure and you try to connect to it, it will fail automatically. Port 3000, you see? It's sometimes you can try to fail, but what's cool with Kubernetes, you can fail in an even more elaborate way. So yeah, that's cool. So now we'll start talking about configuration and secret. So if we want to investigate why both of our deployment or pods are failing, actually, there is 2 different ways. You can describe the pod or get logs out of it, because sometimes your pod might continue functioning, but you will see from, like, let's say the interface aspect, your pod doing, your container sending out garbage results, but it's still marking it as functioning. So the second way is being able to print out logs out of Kubernetes. So we'll start with the first way, which is describe, kubectl describe. Usually you name the object, and then you type the name of the specific object that is failing. Because if you want to describe all instances of your deployment, I'll show you after this one. So when you do kubectl describe pod with the identifier of the unique pod that's failing, you'll get that entire thing. But I don't like reading it in the I don't like reading it in the terminal. So what I usually do is I pipe it, the pipe tool, which is a great tool, by the way. It's one of the best thing coming off Unix. You can pipe it into whatever text editor you have. So in my case, I did it here in Visual Studio Code. And as you can see, you can have all the information, the name of the pod, the namespace, the priority, what node it was put on, the different labels, and like everything, all the information. And it's like a mine of information when it comes to debugging your system. Because when you get to a more complex system and you want to debug it, this is where sometimes stuff gets trickier. So you can see that it is failing. And when you go a bit down, so you can see that it started turning on, and it entered a state of failure. So it was. So I know it's failing because it haven't been able to get both the config map and the secret, but I'm not able to see that error here. Sample ready, desktop, container, back off. Okay, let me get the logs. We might be more lucky, right? So it's kubectl logs. So one cool thing about log is that when you have a multi-container pod, you need to specify which container you want to have the pod on. So it's you can look it up on the documentation, but you can always do kubectl logs -c, the name of the container, and it will return to you the logs of that specific container inside the pod. So let me get the logs like that. So you see, the log is pretty easy to understand. It doesn't have any config map. So this will introduce us to the second part. To the next part, which is about creating a config map. So as I said it during the concepts, you will want to have configuration files within your application, and one way of doing that is, the way of doing that is through config maps, because you can have the other approach, which is mounting volumes, but it will get really verbose inside your manifests. It will add a lot of lines. Whereas with the config map, you have the object config map, and you will have specific fields in your YAML to inject it inside the pod. So that's the main thing. And also, what's cool about working with manifests, YAML files, we call them also manifests, and YAML files this way, is that when you will go onto more complex applications, you'll be able to use an approach that is called GitOps, which is Git for operations, and you'll be able to have a history of changes using Git for your different manifests. So you'll be able to track the changes and also blame the person who did the changes if they broke production. No, I'm joking. Never play the blame game. Yeah. So let's move on to the config map. So yeah, let's go to the config map. Let me get to the step 4. So I'm saying more stuff than during the conceptual presentation before. Just like as I said, it's way easier to illustrate when you are demonstrating, especially with Kubernetes. Because if you look most of the presentations online, you always have the person explaining to you the concepts or the tool, and then doing a live demonstration. So as you can see, we have the config map right here, and it's containing this. So you can either have it this way, but you have tools such as customize with a K. Again, everything with the Kubernetes starts with a K, such as customize, which help you having a patching logic. So you'll have your base manifest, and you'll be able to patch other fields on top of them according to what environment you're deploying. It's really useful. I've used it quite for some deployments, and it has always been handy. It's a bit tricky to get your hands on. It's a bit more advanced, but if you want to know and discover stuff later after this presentation, you can play with manifests using Customize. So here we already have our manifest like that. And what I'll do is again, kubectl apply. So you're kind of starting to understand that I build my container, it's on a registry, I create the manifest, I apply the manifest, I check it for errors, I debug it for errors, and then I apply again. You see, it's quite an iterative cycle. So I apply the kube config. So it's there inside the namespace. However, the pods themselves won't automatically know that it's there because they will grab that config map right at startup. So what I need to do is to restart them. And as we saw earlier, if we delete the deployment, it will delete all the replicas. But we just want to restart the replicas. So one trick to do that is to only delete both pods. So as we saw earlier, both pods have a label, right? So yeah, both of them have a label. So what I can do is kubectl delete pods -n frontend -l app equal frontend. I might have to throw in an all. No. Oh yeah, I'm missing it. Cannot be provided when it's selected. Oh. Okay. This is a bit improvised. That bit is. Oh, you see. So right here, what I did, it's failing again because we're still missing the secret. So no worries, we'll get to the secret in the next part. So as we saw here, we were able, with that command, we were able to delete the pods that had the label where app equal frontend. This is really handy and practical when you get into namespaces where you have hundreds of pods that are assigned to different deployments, and you really don't want to delete something that is not supposed to be deleted. Otherwise, what awaits you is pain and suffering in production. So one more graceful way to do it is to leverage the labels to specify which pod you want to delete. So here I could have done kube control delete pods --all, but I preferred showing a more graceful way of doing it, which is a kubectl delete pods -l, which references the label and the label which I want to filter on. So yeah, that's how you kind of restart your pods so they can grab the config map. So now let's get all of you introduced to secrets. So basically, secrets and config map are the same idea. You want to inject configurations inside the pod, but in the case of config maps, it's non-confidential stuff. In the case of secret, you want to inject really confidential stuff like credentials to database, certificates, and other confidential information that might help your app running, right? So there are several ways, and the way they do it in enterprise or like live production environment is that they use other tools that extend over Kubernetes in order to handle the entire secret life cycle by grabbing the secret directly from a vault. Like the idea of vault is literally like a treasure cabinet. No, not treasure cabinet. The big things that are really heavy and you can put money in. So help me remember that word in English. Sorry? Yeah, a safe. So a vault is like it's like a safe for your secret, and you have several solutions. And basically, you have custom resource definition in Kubernetes that help you handle all that life cycle by grabbing it out of the vault and injecting it into the pod. These are the real life applications. But here, let's get introduced to these topics directly by creating a secret like that, which I totally I don't advise it at all, but it's just for demonstration purpose. So here we're creating a secret, which is a Redis password, like that, and the secret is created. If I do get secrets, it shows me that the secret has been created. Like up until recent versions of Kubernetes, that secret over here, it's just stored in base 64 encoding. So you just need to get the content of the secret and do base 64 decode, and you'll have the password in clear. But from what I understood in the more recent versions, they are trying to solve that. But still, that's why I really don't advise that way, because base 64 is like trying to lock a door with the Cheetos chips, if you've seen that meme online. So it's kind of the same equivalent. So now I have my secret existing, and I need to kind of restart again my pods. So here's what I do. I delete the pods again, and what I see, oh, it's still failing. Okay. Okay, so it's still having that type of error. Open config, no such. So usually, yeah, I get where the error is. So if you remember in step 2, where we created the deployment, right? I had parts that were commented. So let me open that right now. You see in the deployment here, these two parts. So that's what was missing inside. So that's why we had our pods, and they weren't injecting the right solution. I mean the right files, the secrets and the configuration. So right now I uncommented it. Let me save it real quick. Perfect. And then let's restart it again, and it should work. Okay, that's cool. We still have a half an hour. Let's do some live debugging. Okay, delete deployment, front end. Let me do an apply again. Okay, so they're running now. So I really had to recreate the deployment again. So yeah. So that's how you can kind of get your your application running in Kubernetes. These are really simple steps, but I hope that was a good preview into the Kubernetes world. And these concepts are reused heavily when you deploy other solutions such as Kubeflow and many other solutions based on Kubernetes as well. Any questions? Okay, the group is as shy as earlier. Oh, yeah. I shared the Git repo in my presentation. So can you go to my username, which is Blisser with a capital B? And it will be the repo called hands-on sample. Wait, let me... Can you see it now? Do you see it? Okay. So we have a bit more time. Do you want to do the first bonus or not? Or you have more questions? Or your brains got enough of Kubernetes for today and you want to still have room in your heads for other workshops? I'll also put the deck slide on that repo as well, so don't worry. You know what I'll do? I'll add the deck slide right now. Okay. Perfect. Any more questions? Doubts? Things you would be curious about? Other steps? How you can use it in your daily job? Yes? Oh, yeah. Let me get the port forward real quick. Forward, 3000, 3000. Oh, yeah. That's the right one. So it might fail because it's like an API endpoint. So we might need to do what's called a curl. So let me do that real second. Oh. So it's telling me 404 page not found, but that means the endpoint is up, but there is no HTML content. So if I get to the original on which I based this tutorial on it, let me grab their curl command. Oh yeah, I can directly do localhost/API. Let me do a real quick. So curl localhost 3000/AP. might fail because I wasn't able to run the ingress that provides the path /API. Yeah, still same. But at least it's not a 500 error or any other type of error. So this means it's running. But it's a good exercise for you later at home if you want to go a bit further and delve deeper. But yeah, these are like the basics, no ingress, no that type of fluff. Does that answer your question? Okay. Nothing else. So it's been a real pleasure to host this workshop, and I hope I'll see you around because I'm staying here also tomorrow. So if you see me, don't hesitate to come and have a chat with me. I'm always happy to meet new people and discuss MLOps with all of you. Thank you very much.